Hello students, welcome to Breedmark Academy. Myself LS Nanda. In this particular video, I am going to discuss the detailed solutions of mathematics section of KVPY exam for the stream SBSX that was held on 22nd May 2022. Actually, this exam contains two parts, part 1 and part 2. Both the parts have questions on mathematics. In this particular video, I am discussing part 1 mathematics section only. I will make another video in which I am going to discuss part 2 also. Now, part 1 contains 20 questions on mathematics. So, we'll be discussing them one by one. Here is the first question. You can clearly see it is a question based on the concepts of permutation, combinations and probability. The question says, consider the set of all 7-digit numbers found by the digits 0, 1, 2, 3, 4, 5, 6, each chosen exactly once. If a number is randomly drawn from this set, then the probability that it is divisible by 4 is. Now basically, we have to, first of all, because we know that probability of an event is number of favorable cases upon number of exhaustive cases. Now, to find the number of exhaustive cases, we will have to find the total number of 7-digit numbers that can be found by using these digits exactly once. Now, for that purpose, I am making 7 blocks. Now, one thing we have to keep in mind is that since one of the digits is 0, we need to be careful that the first place cannot contain 0, because otherwise it will become a 6-digit number, right? So that means this particular place can only be filled in 6 ways. Why 6? Because you can fill them by any digit from 1, 2, 3, 4, 5, 6. But you cannot place 0 over here. Now for the second place, I can fill this particular place in 6 ways again, because now 0 can be filled over here. But that number which I filled in the first place won't come, right? Similarly, next will be filled in 5 ways, because we cannot reuse the number which we have already filled in the previous places. Fine. So this is why every time we have to reduce 1. By using fundamental principle of counting, we'll be multiplying all of these cases, and this becomes 6 into factorial 6. That means there are total 6 into factorial 6 such numbers. Fine. So this is going to be our exhaustive number of cases. Now we move towards finding favorable number of cases. And to find favorable number of cases, you will have to find those numbers which are divisible by 4, right? And students, for divisibility by 4, you must know that any number whose last 2 digits, the number formed by whose last 2 digits is divisible by 4, then the whole number is divisible by 4. For example, it is 1824, right? So to check whether this number is divisible by 4 or not, you just check 24. Since 24 is the multiple of 4, so that's why 1824 will also be divisible by 4. Fine. So that means we'll have to form such groups whose last 2 digits form a number which is a multiple of 4, right? Now I'm starting with 0. 0, 4 can be the first group, because 0, 1, 0, 2, 0, 3, 0, 5, 0, 6 are not possible. Then we'll be starting with 1. 1, 2, then 1, 6. Fine. Then we start with 2, 2, 0, 2, 4. Then we move to 3. It is 3, 2, 3, 6. Then we move to 4, 4, 0. We cannot write 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. They are not possible. Now we move to 5. It is 5, 2, then 5, 6. And lastly, we write 6, 0 and 6, 4. Fine. These are the possible groups. Now students, to find the favorable number of cases, you will have to be very careful, because there are going to be two categories now. First category is going to be of those numbers that are having 0 in any of their last 2 digits. Right? This is the first category. And the second category is of those numbers which are not having 0 in any of their last 2 digits. Now I'm discussing the first case. Let's take 0, 4. This is the first group, right? Because this particular treatment 0, 4, 2, 0, 4, 0 and 6, 0 is going to be same for all of these groups. So I will be just finding the total number of numbers for this group 0, 4, and I will be just multiplying it by 4, because all other groups which I have marked 0, 4, 2, 0, 4, 0, 6, 0 will have the same number of numbers, right? Why I'm saying this? Because when we find the number of numbers that contain last 2 digits as 0 and 4, then now I'm sure that 0 is not going to come in the first place. That means we have got rid of 0, because 0 was creating trouble. So now safely I can write that the first place can be filled by any of the remaining 5 digits. Fine. Then 4, then 3, then 2, and then 1. That means factorial 5 will be the number of numbers for this group. Now since there are 4 such groups, so that means total number comes out to be 4 into factorial 5 for the first case. I think this should be clear to you. Now we move to the second case. Now we'll be discussing those groups, these remaining groups 1, 2, 3, 4, 5, 6, 7 and 8 such groups are there. Now we are going to discuss only one of them, and we'll be just multiplying the total number of numbers obtained in this particular group by 8. Why I'm saying 8? Because all of the other groups are going to be treated in the same way, right? Now we have to fill the first 5 places by the remaining 5 digits. But this time the first place cannot be filled with 0. This is why I took the 2 cases separately. Now the first place cannot be filled by 0 means the first place can be filled in how many ways? I cannot fill 1 and 2, I cannot fill it by 0. So that means now I'm just left with 4 numbers, right? But in the second place, now I can fill it by 0. But I cannot fill it by that number which I have already used. So that means again 4, then 3, then 2, and then 1. So this is how much? It is 4 into factorial 4, right? But since there are 8 such groups, so that means the total number of numbers will be 8 into 4 into factorial 4, or I can say it is 32 into factorial 4. So now students, the required probability, I am calling this event by E, and the probability that the number chosen, because we are selecting a randomly any number from this particular set of the numbers obtained, then it is going to be number of favorable cases divided upon number of exhaustive cases. So number of exhaustive cases is 6 into factorial 6, and number of favorable cases we have got as 4 into factorial 5 plus 32 into factorial 4. Now to make the calculations easier, what I am doing, I am dividing numerator and denominator by factorial 4, because factorial 4 is coming common from the numerator, and we can also take it out common from the denominator, because factorial 6 is nothing but 6 into 5 into factorial 4. So now this becomes probability E becomes 4 into 5, which is 20, plus 32 divided upon 6 into 6 into 5 only, because factorial 4 we have cancelled up and down. So this is 52 upon 180. Just divide up and down by 4. So you'll be getting 13 upon 45. So that means option B is the correct one. Now it was a nice question. Now we move to the second problem. Now students, this is the second question. The question says, let a, b, x be positive real numbers with a not equal to 1, x not equal to 1, ab not equal to 1. Suppose log b to the base a equal to 10, and this given expression is there, log x to the base a into log b by a to the base x whole divided upon log b to the base x into log x to the base ab equal to p by q, where p and q are positive integers which are co-prime. Co-prime means p and q are not going to have any common factor. That means only one is going to be common among them. Rest, there is not going to be any other factor which is common. Then p plus q we have to find, right? Now, to solve this question, you must be familiar with all the properties of logarithms, because it's a question based on logarithm. First of all, log b to the base a equal to 10 is given. So I can write b equal to a to the power 10, because this is just the definition of logarithm, right? Now, log x to the base a, it is given. So I can write it like log x divided upon log a. I am taking the base of both of these logarithms as same. Let us consider they are having the base as 10, right? This is called base changing or base changing law or base changing property of logarithm. Now similarly, the second one, log b by a to the base x, I am writing as log b by a divided upon log x whole divided upon log b to the base x, I am writing as log b upon log x, and this log x to the base ab I am writing as log x upon log ab. I am taking the base of logarithm in all of these terms as 10, right? You can take any base, but I am taking 10 just for your convenience, because 10 is a common base used for logarithms. Now, why did we use this property? Because this log x and log x will cancel, log x and log x will cancel in the denominator also. So now this implies that log b by a to the base a into log ab to the base b. What I have done, I have taken log ab in the numerator from the denominator, and log b will come in the denominator. So after that we have joined both of them. Those students who do not know the property which I am using, let me explain them. Log p to the base q can be written as log p to the base r divided upon log q to the base r. This is the property I am using over here, right? Now, to solve it further, what I can do, I will just use b as a to the power 10. So this is going to become, ultimately we have to simplify this expression and reduce it to the simplest form. From there we'll be getting the numerator as p and denominator as q. This is the question only, and then we'll be adding p and q. Now when I put b as a to the power 10 over here, it becomes log a to the power 9 to the base a into log a to the power 11 to the base a, and this is p by q, right? Now students, the value of this expression is nothing but 9, and in the base over here it is a to the power 10. Just please pay attention, the base in this case is a to the power 10 because base was b. Now we have another property, log m to the power p to the base n to the power q can be written as p by q into log m to the base n, right? So according to this property, I will be writing it as 11 by 10 to the into log a to the base a, and log a to the base a is nothing but 1. So that means p by q becomes how much? It becomes 99 upon 10, and you can clearly see this fraction is in the simplest form because there is nothing common in 99 and 10. Both of them are co-prime. So this satisfies our given condition of the question. Hence p plus q will be nothing but 99 plus 10, which is 109. So that means option C is the correct one, right? Now we move to the next question, the third one. Now students, this is really a wonderful problem. The question says, let x, y, z belongs to close 0 to 1. Then we are supposed to find the maximum value of square root of mod of x minus y plus square root of mod of y minus z plus square root of mod of z minus x. Now without loss of generality, I can assume that x greater than or equal to y greater than or equal to z. You can also assume y greater than or equal to z greater than or equal to x, or x greater than or equal to z greater than or equal to y. It is not going to affect our answer because ultimately one number will be greater than or equal to the second, and second will be greater than or equal to the third. Now I am taking x minus y equal to a and y minus z equal to b. Fine. If I add both of them, I will be getting x minus z equal to a plus b. Now students, I am taking our given expression as e. So e will become square root of mod of a. Now obviously x is greater than y, so it is just square root of a, plus square root of b, plus square root of, I can write here mod of a plus b or just a plus b, because a plus b is positive. Why I'm saying this? Because mod of z minus x is same as mod of x minus z, and we have got x minus z as a plus b. Fine. Now at this stage, we need to think carefully, and the step which we are going to take further will lead to our answer. And here I am writing a plus b less than or equal to 1. Why I'm saying this? Because a represents the distance between x and y on the real number line, and b represents the distance between y and z on the real number line. And obviously, since these three numbers x, y, z are falling in this particular interval, so x minus z, which is the gap between x and z, cannot be more than 1. That means a plus b has to be smaller than or equal to 1. Fine. So that means b is less than or equal to 1 minus a. If I take square root on both the sides of this inequality, I am going to get this. Let's add root a on both the sides of this inequality. So this is our first inequality. Now from here, I can write square root of a plus b less than or equal to 1. Let's call this inequality number 2. Now students, we can add both of these inequalities. Now addition of inequalities is possible, but while writing equality sign, we need to be careful. For example, sine theta we know is less than or equal to 1, and cos theta is less than or equal to 1. If I add both of them, I cannot write sine theta plus cos theta less than or equal to 2. Why? Because we know that sine theta plus cos theta's maximum value is root 2. It's not 2. Because for sine theta plus cos theta to be equal to 2, both the sine theta and cos theta have to be 1, which is impossible. Because when sine theta is 1, cos theta has to be 0. Right? So that means while adding any two inequalities having less than or equal to sign or greater than or equal to sign, you must be careful while attaching the sign of equality. Equality can only be attached if both of these inequalities turn into inequality in the same situation. For example, it is happening here. In this particular second inequality, equality will hold when a plus b becomes 1. And you know that when a plus b becomes 1, then b will be equal to 1 minus a. So that means equality will also hold in the first inequality. That means root a plus root b will become equal to root a plus square root of 1 minus a. So that means here I can definitely add them and write root a plus root b plus square root of a plus b less than or equal to root a plus square root of 1 minus a plus 1. Now it's very much clear that the maximum value of e will now depend on the maximum value of this expression which I have written on the right hand side. So I can write e less than or equal to root a plus square root of 1 minus a plus 1. Now there are two ways to find the maximum value of this underlined expression. Either you can assume a as sine square theta, because ultimately a is lying between 0 to 1. So we can take a as sine square theta, and square root of 1 minus a will become cos square theta. That is only cos theta, because 1 minus a will become cos square theta. So square root of 1 minus a will become cos theta. So that means sine theta plus cos theta plus 1. Right? E becomes sine theta plus cos theta plus 1. So we know that the maximum value of sine theta plus cos theta is nothing but square root of 1 plus 1, which is root 2. So that means E max becomes how much? It becomes root 2 plus 1. This is one way. Another way to get the maximum value of this expression, underlined expression, is you can differentiate this. It's a function of a, right? Now I'm explaining you this second method. Now we can take f of a equal to root a plus square root of 1 minus a plus 1. Let's determine the maximum value of f of a. We know that a belongs to closed 0 to 1. Now f dash a becomes how much? It is 1 upon 2 root a minus 1 upon 2 under root 1 minus a. To find the maximum value of this expression, f dash a must be 0. So that means root a becomes equal to square root of 1 minus a. When we square both of them, we get 2a equal to 1, or a is just equal to half. Now there are 3 points at which we can decide the maxima or absolute maxima of f of a. One is a equal to 0. When we put a equal to 0, f of 0 becomes how much? It is 2. When we put a equal to 1, it becomes f of 1 becomes again 2. And when we put a equal to half, at this time f of half becomes how much? It is 1 upon root 2 plus 1 upon root 2. That means 2 upon root 2, or just root 2 plus 1, which is obviously bigger than 2. So that means at a equal to half, this function becomes maximum, and its maximum value is root 2 plus 1. So obviously the maximum value of e becomes how much? It is root 2 plus 1. Now hence option A is going to be correct. To find the maximum value of e, you can adopt any of these two ways. First was a method based on trigonometry, and second is method based on maxima and minima. Now we move to the next question. Now this is a good question on continuity. The question says, let capital R be the set of all real numbers, alpha belonging to capital R be positive. Define a function fr to r by f of 0 equal to 0 and fx equal to mod x to the power alpha into summation n varying from 0 to infinity 1 plus x square whole power minus n for x not equal to 0. Then the set of all real values alpha for which fx is continuous at x equal to 0 has. Now students, we know that for a function to be continuous at a certain point, its limit at that point must be equal to its value at that point. That means for the function fx to be continuous at 0, limit fx x tending to 0 should be equal to f of 0. And f of 0 is equal to 0. This is given to us. So that means limit fx x tending to 0 must come equal to 0. Now fx is mod of x to the power alpha into summation n varying from 0 to infinity 1 plus x square whole power minus n. This is mod x to the power alpha into, now this n is obviously a whole number. So when we put n as 0, this is 1 plus x square to the power 0, which is 1, plus 1 upon 1 plus x square, plus 1 upon 1 plus x square whole square, plus 1 upon 1 plus x square whole cube, and so on till infinity. Now clearly, this series inside the bracket is forming an infinite geometric progression with the first term as 1 and the common ratio as 1 upon 1 plus x square. Now students, it is mentioned that x is not equal to 0. So that means x square is going to be greater than 0 and less than infinity. Fine. So I can say that x square plus 1 is greater than 1 and less than infinity. So I can also say that 1 upon 1 plus x square is greater than 0 and less than 1. Why I'm doing this? Because the common ratio of this particular geometric progression lies between 0 to 1. So this means I can find its sum, and the sum is given by the formula a upon 1 minus r, we know. So this is going to be 1 upon 1 minus 1 upon 1 plus x square. So this comes out to be 1 plus x square divided upon 1 plus x square minus 1, which is nothing but x square. So that means we are left with 1 plus x square divided upon x square. Fine. This is the function fx when we have simplified it. Now students, we have got fx as mod x to the power alpha into 1 plus x square divided upon x square. If I put alpha as 2, then fx becomes x square into 1 plus x square divided by x square, means this is just 1 plus x square. Now in this case, when I take the limit at x tending to 0, then it becomes 1. That means at alpha equal to 2, the function is not going to become continuous at x equal to 0. When we put alpha equal to 2, it is not going to be continuous at x equal to 0. But if I take alpha as 3, 4, 5 and so on, take any value greater than 2, I am only concentrating upon integral values at present. Fine. So when I take alpha as 3, fx becomes how much? It becomes mod x cube. So I can separate it as x square into mod x. So it becomes mod x into 1 plus x square. Now we know that the product of any two continuous functions is always continuous. 1 plus x square is a polynomial function. It is always continuous, and mod x is also always continuous. So hence at x equal to 0, fx will definitely be continuous. Fine. You can also check it by using the method of LHL and RHL, but this is better one. So similarly at alpha equal to 4, what you can do? Fx becomes how much? You can write mod x to the power 4 as x to the power 4. So it will become x square into 1 plus x square. It's a polynomial function. So I can definitely say now for alpha to the power 6, alpha to the power 8 and so on, it will directly become a polynomial function. So there are many values of alpha, or I should say infinite values of alpha, for which the function fx will become continuous at x equal to 0. Right? You can keep on trying like this. So there are more than 4 elements, or option D is the correct one. Right? Now we move to the next question. Now in this question, all integers are represented in base 10. Consider the set E of positive integers n having the property that when any non-zero digit d is written to the right of n, the resulting number is divisible by d. Let capital N be the smallest element of E. The product of the digits of n is. Now students, first of all, when you write any digit to the right hand side of any number, then how can you express the resulting number in terms of the previous number and that digit? Suppose I am having 174 and I write 2 onto its right hand side. Then I can write 1742 as 10 times 174 plus 2. It does not matter how many digits n is having. For example, if n is 2 and you write 2 onto its right hand side, it becomes 22. So you can still write 22 as 10 times 2 plus 2. Fine. So according to this, our resulting number will now become 10n plus d. And question says that 10n plus d is divisible by d. That means 10n plus d upon d is going to be an integer. Right? Or I can say 10n upon d plus 1 is an integer. This means that 10n must be divisible by d. And we have to find the smallest value of n for this to be possible. Fine. And we have to check for all possible values of d, because digit d can be 1, 2, 3, 4, 5, 6, 7, 8, 9. It can be any value from these these 9 numbers, right? Now when I put d as 1, obviously every number is divisible by 1. When I put d as 2, then it's not necessary that n must contain 2, because 10 is already having 2 as a factor. Fine. But when I put d as 3, then 10 does not contain 3 as a factor. That means n must have 3 as a factor, because only then 3 will cancel out, otherwise not. Now when I put d as 4, 1, 2 gets cancelled from 2, which is a factor of 10, and another 2 must be present in n. That means n must have 2 as a factor, right? Now we move to 5. 5 is present in 10, so there is no requirement that n must have 5 as a factor. Then we put d as 6. I have already told you that n contains 2 and 3, so it will be divisible by 6. Now when we put n as 7, then 7 is not present in 10 as a factor. That means n must have 7 as a factor. Now please pay attention that I am trying to find the smallest value of n. This is why I am not attaching any extra factor, right? Now when we put the value of d as 8, we had 2 as one of the factors of 10. 2 was already present. N was already having 2. That means 4 is present in the numerator. But since d is 8 now, that means one more 2 is required. So it means that capital N, which is the smallest possible value of n, now must have 2 into 2. That means 2 must be present 2 times into 7 into 3. I have used all of 3 of them, and one more 2 I have attached, because now I have to make 10 and divisible by 8. Now when we move to 9, when we put d as 9, then we already had n containing 3. but to make it divisible by 9, n must be having 3 2 times as its factor. Otherwise, it won't be divisible by 9. So that means this is the situation. N will be containing 3 2 times as a factor and 2 2 times as a factor and 1 7. So this is the smallest possible value of capital N. And this is our desired number, right? Now let's calculate its value. It is 4 into 9, 36 into 7. So this becomes 7 6 42 and 7 3 21. This is 252. That means smallest such number is 252. And we are required to find the product of its digits. So it becomes 2 into 5 into 2, which is nothing but 20. So that means option A is the correct one. It was a nice question. Now we move to the next problem. Now students, this is a nice problem on continuity. The question says, let capital R be the set of all real numbers. The number of continuous functions f r to r such that for all real x, f of x plus f of 2x is equal to 0 is. That means we have to find the number of continuous functions f r to r such that they satisfy this equation. So that means f of 2x is equal to minus fx. If I replace x by 2 in this particular equation, I am going to get f of x equal to minus f of x by 2. Right? So that means I can write f of 2x equal to minus fx further equal to f of x by 2. Fine. Now if I replace x by 2 again in the equation number 1, I am going to get f of x by 2 equal to minus f of x by 4. I am calling this equation number 2. So now I can write f of 2x equal to minus fx equal to f of x by 2 further equal to minus f of x by 4. Again, if we replace x by 2 in equation number 2, we are going to get f of x by 4 equal to minus f of x by 8. Fine. So that means now I can write f of 2x equal to minus fx equal to f of x by 2 further equal to minus f of x by 4 further equal to f of x by 8. Fine. Now this will continue in same way, and the next term will be minus f of x by 16, then equal to f of x by 32 equal to minus f of x by 64 and so on. So that means I can write f of 2x is equal to plus or minus f of x upon 2 to the power n, because it has formed a chain of recursion. Fine. Now when n is approaching infinity, that means n becomes very large, then in that case x upon 2 to the power n will definitely approach 0. If I call x upon 2 to the power n as y, then I can say, since this function is continuous at every point, that means limit f y tending to 0 will become f of 0. And what is f of 0? Students, if you put x equal to 0 in this particular equation, you will be getting f of 0 plus f of 0 equal to 0. So that means f of 0 is nothing but 0. So we conclude that limit f y tending to 0 is equal to f of 0, which is further 0. That means ultimately I can say, since this function is a continuous function, then the value of this entire chain f of 2x equal to minus fx equal to f of x by 2 and so on is going to be what? It is going to be 0 only. So that means f of x equal to 0 is the only function that is going to satisfy this condition. No other function is possible. So hence option B is the correct one. Now students, we move to the next question. Now students, this is the next question. It says, let E denote the set of all integers A such that the point of intersection of the parabola y equal to x square plus 2ax plus 2021 with x-axis has rational coordinates. Then the largest element of E is. Now we know that whenever any curve intersects x-axis, then at the point of intersection of the curve with x-axis, the value of y becomes 0. Because for any point lying on the x-axis, y is always 0. So that means we will be putting y as 0 in this equation of the parabola. And from the question, it's very much clear that the roots of this equation will be rational. That means the value of x which we are going to get from this equation will be a rational number. And we have to find out the largest value of a such that largest integral value of a such that the roots of this equation come out to be rational. Now first of all, let's find the roots of this equation by using quadratic formula. So it is minus 2a plus minus square root of 4a square minus 4 into 2021 whole divided upon 2. I have used the quadratic formula x equal to minus b plus minus root d upon 2a, where in this formula a refers to the coefficient of x square, right? Now this becomes minus 2a plus minus, I can take out 4 outside from the square root, it will become 2 times square root of a square minus 2021 whole divided upon 2. Now from here I am going to get x equal to minus a plus minus square root of a square minus 2021. Now students, this value will become a rational number for some integer a only when the value inside the square root a square minus 2021 comes out to be a perfect square. That means a square minus 2021 must be the square of some integer, right? A square minus 2021 I am writing as b square, where b is any other integer. Why I am saying this? Because a is an integer, so a square will be an integer, so a square minus 2021 will definitely be an integer. Now this integral quantity may be a perfect square or may not be a perfect square, but ultimately to get x as a rational number, we will have to get rid of this square root sign. So that means a square minus 2021 must be a perfect square of an integer, right? So that's why I've assumed a square minus 2021 as b square, where b is any integer. Now from here we will be getting a square minus b square equal to 2021. Now students, 2021 can be broken in two ways. Either I can write this as 2021 into 1, or we can write this as 47 into 3, 43. There are only two ways. It's an interesting number. Either it can be written as 2021 into 1, or we can write this as the product of two prime numbers. Now why I'm doing this? Because ultimately I have to get a and b. Now a square minus b square now can be written as a plus b into a minus b. Now since both a and b are integers, so that means a plus b and a minus b will also be integers. So if I put a plus b into a minus b as 2021 into 1, I am discussing the first case. Then from here we can easily write a plus b as 2021, because a plus b is going to be the bigger factor and a minus b is going to be the smaller factor. So it is going to be 1. If we add both of them, we get 2a as 2022, or from here a comes out to be 1011. That means b will become 1010. Or I can say for a equal to 1011, the value B will be 1010. That means the value under the square root here will be 1010 whole square. Fine. Now let us discuss the second case. If we take a plus b into a minus b as 47 into 43, then from here we conclude that a plus b is equal to 47 and a minus b is equal to 43. If we add both of them, then we get what? We get 2a as 90 or a as 45. If a is 45, clearly b is equal to 2. Now, ultimately, we wanted the largest value of a, largest integral value of a, right? So that means a equal to 45 will be rejected, and now we'll be accepting a equal to 1011. So that means option C is the correct one. Otherwise, both of these answers could have been selected as the values of a if no condition like this would have been mentioned, as we want the largest element only. But since it requires largest element, so that's why a will be 1011. It was a nice question. Now we move to the next problem. Now this is the next problem. The question says let m comma n be real numbers such that m greater than or equal to 0 less than or equal to root 3 and n greater than or equal to minus root 3 less than or equal to 0. The minimum possible area of the region of the plane consisting of points x, y satisfying the following inequalities. Y greater than or equal to 0. Next is y minus 3 less than or equal to mx. And last is y minus 3 less than or equal to nx. Now, first of all, let's make x-axis and y-axis. This is the origin. Now, you can clearly see y equal to 0 is what? It is x-axis. And from this y minus 3 less than or equal to mx, we get a line y equal to mx plus 3. And from this inequality y minus 3 less than or equal to nx, we get a straight line y equal to nx plus 3. Now, since n is negative, means this is the line making obtuse angle with positive x-axis, y equal to nx plus 3. Fine. And its y-intercept is 3 units. That means it is going to intersect y-axis at the point 0, 3. And we can just draw it like this. Y equal to nx plus 3. Fine. Similarly, this is another line having positive slope and passing through the same point 0, 3. And it is going to make acute angle with positive x-axis, right? Now let's find the coordinates of these points as well. This is minus 3 upon n comma 0, and this is going to be minus 3 upon m comma 0. Fine. Now students, we have to calculate the minimum possible area of the region enclosed by these inequalities. Y greater than or equal to 0 means the area of the region above the x-axis. Y less than or equal to mx plus 3 means, because when we put origin in this inequality, then the inequality gets satisfied, because 0 is less than or equal to 3. Means we have to take that portion of this line or that region of this line, because every line divides the plane into 2 parts. So we have to select that particular part in which origin lies. Similarly, for the line y equal to nx plus 3 also, we have to take that region in which origin lies, because origin is satisfying the second inequality as well. 0 less than or equal to 3. So ultimately we conclude that means we have to find this shaded portion. We have to find the area of this shaded region and we have to make it minimum possible. That is the interesting thing. Now clearly it is forming a triangle and the area of the triangle we know is how much? Half base into height. Height is fixed here. It is 3. What is the length of the base? The length of the base is how much? Because here n is negative. So I can say minus 3 by n is going to be a positive quantity. This one. Right? And m was positive. So this particular distance is going to be how much? We will be taking this distance as 3 by m and not minus 3 by m. Please mind it. Fine. So when I calculate the area of this particular region, let's call this region as ABC, then area of triangle ABC is going to be how much? It is half base into height, half into 3. Base is going to be 3 upon minus 3 upon n plus 3 upon m. Fine. I have told you the reason for this. Just take out 3 common. This is 9 by 2 and inside the bracket we get 1 upon m minus 1 upon n. Now students, we need to calculate the minimum possible value of this area. Now just look at the given inequalities, these two inequalities. M is a positive number lying between 0 to 0 to root 3. So that means I can say 1 upon m. I am just taking the reciprocal of this inequality is going to lie between what? This is going to be greater than or equal to 1 upon root 3 to infinity. Fine. Now similarly, n is lying between minus root 3 to 0. So that means minus n is going to lie between 0 to root 3. This is minus n. First of all, you need to make this quantity positive. Now you will be taking the reciprocal of this. So it becomes minus 1 upon n lying between how much? Greater than or equal to 1 upon root 3 to infinity. Fine. When we take the reciprocal, signs would automatically get reversed. Because if a and b are two positive numbers and a is greater than b, then obviously 1 upon a will be smaller than 1 upon b. Fine. So now just add both of them. When you add both of them, you get 1 upon m minus 1 upon n greater than or equal to 2 upon root 3 and less than infinity. So now we are just interested to find the minimum value of this area, and we know that the minimum value of 1 upon m minus 1 upon n has come as 2 upon root 3. So what is the answer? It is 9 upon 2 into 2 upon root 3. So just do the calculations. This becomes 3 root 3. So that means option C is the correct one. Now we move to the next question. Now students, this is a nice question. The question says, let AB be the diameter of a semicircle S. The locus of the centers of circles which are tangent to AB and to S is an arc of. We have to check which of them is correct. A circle, an ellipse, a parabola or a cycloid. Now let us draw x-axis and y-axis. I am taking this semicircle's center at origin and the diameter AB lying on the x-axis. You can take it anywhere else just for the sake of convenience, because ultimately I have to get the equation of the locus. Only from that we'll be able to judge whether it is ellipse, parabola or circle. That's why I'm taking it, because we can allot coordinates to any point according to our choice. That means we can set coordinate system as per our own choice. So I am setting the center of this semicircle at origin. Fine. Now, many circles will be there that will be touching both S, this is S, semicircle S, and AB, right? And we have to find the locus of their centers. Now, we are going to be just taking one circle. With the help of one circle only, we'll be able to get the answer. Now, let us take this one. I am joining the center O of the semicircle with the center O dash of this particular circle. Let us assume that the coordinates of the center of this circle as x comma y. Fine. I am taking the radius of the original semicircle as r. It is going to be fixed. That means OA is equal to OB is equal to r. Let's take this particular point as P. This is the point of contact of the inner circle and the bigger semicircle. Now we know that whenever two circles touch each other internally or externally, then their centers and their point of contact are always collinear. That means O dash and P will be collinear. So I can say OO dash equal to OP minus O dash P. Now students, if I draw perpendicular from O dash onto AB, clearly it's going to be of the length y. That means the radius of this particular circle is going to be y, because I assume the coordinates of the center of this circle to be x comma y. Fine. So y will be the radius for this circle. Now O dash P is going to be y, OP is r. So that means OO dash comes out to be how much? R minus y. But O dash also represents the distance of origin and O dash. Since the coordinates of O dash are x comma y, so OO dash I can write as square root of x square plus y square. Right? So that means if I equate square root of x square plus y square with r minus y, what do I get? I get square root of x square plus y square is equal to r minus y. If I square both sides now, I am going to get x square plus y square equal to r square plus y square minus 2ry. Now clearly, if I cancel y square on both the sides, I am going to get x square equal to r square minus 2ry. Now x square becomes how much? If I take out r common from the right hand side, it becomes r into r minus 2y. We can further write this as x square equal to minus r into 2y minus r. Or we can also write x square equal to minus 2r. Inside the bracket, it is y minus r by 2. Now students, you can clearly see it is going to represent a downward parabola. Now in our case, it's a downward parabola, but in general, we can say it is going to be a parabola. Fine. So hence, we can definitely say that the locus of the centers of all of these inner circles are going to represent a or going to be a part of or arc of a parabola. Right? Now we move to the next question. Now this is the next problem. It says let theta belonging to the first quadrant, because theta greater than 0 less than pi by 2, be an angle such that the equation x square plus 4x cos theta plus cot theta equal to 0 has equal roots for x. Then theta in radians is. Now it's a direct question related to trigonometry. Now it's mentioned that this particular quadratic equation has equal roots, and we know that when any quadratic equation has equal roots, then its d is equal to 0 or b square is equal to 4ac. So that means 4 cos theta whole square will be equal to 4 cot theta. That means 16 cos square theta I can write equal to 4 cot theta, and this becomes 4 cos square theta equal to cot theta. Now we can write 4 cos square theta equal to cos theta upon sin theta, because cot theta is nothing but cos theta upon sin theta. And now students, since theta lies in purely in first quadrant, that means theta is greater than 0 less than pi by 2. So I can directly cancel cos theta on both the sides, because cos theta cannot be 0. So that means 4 cos theta becomes equal to 1 upon sin theta. Or when we cross multiply, we get 4 cos theta sin theta equal to 1. This means 2 into sin 2 theta, because sin 2 theta is nothing but 2 sin theta cos theta. So 2 sin 2 theta becomes equal to 1, or sin 2 theta is equal to half. Now, since theta was lying in 0 to pi by 2, then it means that 2 theta will be lying in 0 to pi. And it covers two quadrants, first and second. And if sin 2 theta is equal to half, it clearly means we are going to get two values for 2 theta. The first value will be lying in the first quadrant, which is nothing but pi by 6, because sin 30 degree is half. And second value is going to be 180 degree minus 30, which is 5 pi by 6, right? So that means accordingly theta is going to become pi upon 12 or 5 pi upon 12. So hence option B is the correct one. Now students, we move to the next question. Now students, this is a direct question on increasing and decreasing functions. The question says the graph of the function fx equal to cos x upon cos 2x in the domain open interval minus pi by 4 to pi by 4 is. We have to check on to which particular part in this interval the function is increasing or decreasing. Now we know that to find the interval for increasing and decreasing, we must find f dash x. In those regions where f dash x is positive, there the function will be increasing, and in those regions where f dash x is less than 0, the function will be strictly decreasing, right? Now we differentiate fx with respect to x, so we'll have to apply quotient rule. In the denominator we'll be getting cos square 2x. In the numerator it is going to be cos 2x into minus sin x minus cos x into minus 2 sin 2x, right? So f dash x becomes how much? It becomes, I can write this as sin 2x as 2 sin x cos x. So it becomes 4 sin x into cos square x minus the first term I am writing as the second term because it is having minus sign. So it will become sin x into cos 2x, right? Now this becomes, I can take out sin x common. So in the numerator I am going to have sin x into 4 cos square x minus cos 2x, and in the denominator we are having cos square 2x. So now f dash x becomes how much? Sin x into, now students, we know that cos 2x is nothing but 2 cos square x minus 1, right? So when we put cos 2x as 2 cos square x minus 1, the expression becomes 4 cos square x, sin x is already outside, 4 cos square x minus 2 cos square x plus 1 in the numerator, and in the denominator we are already having cos square 2x. So this becomes sin x into, inside the bracket it is 2 cos square x plus 1, in the denominator it is cos square 2x. Now students, 2 cos square x plus 1 is always positive because it is the sum of two positive numbers, positive expressions, and cos square 2x is again positive. So that means everything now depends upon sin x. If sin x is positive, then f dash x will be positive. Now in this particular interval minus pi by 4 to pi by 4, we know that in the fourth quadrant sin x is negative. That means from the region minus pi by 4 to 0, which lies in fourth quadrant, this derivative f dash x will be strictly negative, because here sin x is going to be negative. So negative into a positive quantity is a negative number. Fine. That means in this particular interval, fx is going to decrease in the interval minus pi by 4 to 0. And in 0 to pi by 4, which lies in first quadrant, f dash x is going to be positive. That means here fx is going to increase. So that means as per the options, option C is the correct one, decreasing on minus pi by 4 to 0 open interval and increasing on open interval 0 to pi by 4. Right? Now we move to the next question. Now students, it's a wonderful tricky problem. The question says the number of differentiable functions y going from open interval minus infinity to close 0 to infinity, satisfying y dash equal to 2 root y, where y at 0 is equal to 0 is. Now basically in this question we have to tell how many differentiable functions can be formed which meet these given conditions. First one is its domain is capital R, its range is greater than or equal to 0. It must satisfy this differential equation and its value at x equal to 0 should be 0. Right? Now when we look at this differential equation, we can clearly see y equal to 0 is such a function that will always satisfy it. Why I'm saying this? Because when y is equal to 0, then dy by dx is obviously 0. So left hand side of this differential equation is obviously equal to right hand side. That means this is one of the functions that is going to satisfy this differential equation. Secondly, its domain is capital R. It's defined for all real numbers because it is just the x-axis, and its range is obviously falling in the given category, close 0 to infinity, and its value at x equal to 0 is obviously 0. Right? Now when y is not equal to 0, we start with this differential equation and divide both sides of this differential equation by root y, because y is not equal to 0, so we can divide by root y. So I'll be getting 1 upon root y into dy is equal to 2 dx. Fine. So if I integrate both sides, then what do I get? I will be getting y to the power half divided by half, or just 2 root y, equal to 2x plus c. So that means I can say root y is equal to x plus k, where k is nothing but c by 2, or just a constant. Now students, there is very important point that you must note over here, and that is root y is equal to x plus k. That means x plus k cannot be negative. Moreover, x plus k cannot be 0 also, because y equal to 0 is not allowed in this case. So that means x should be greater than minus k. Or I can say the function will have this sort of format, y equal to x plus k whole square, where x is greater than minus k. Fine. Now let's see how many such functions which are going to have this sort of format can be formed. The first is, obviously I have told you, y equal to 0. Second is y equal to, I am creating branched functions and I am taking y equal to x square. When I put k over k as 0 in this, obviously y becomes x square, which is going to be valid for x greater than 0, right? And for x less than or equal to 0, I am taking the value as 0 itself, because it's such a function that is going to satisfy all the given conditions. First of all, we have defined the function for all real numbers. That means domain is capital R. Secondly, you can notice that the range of this function is going to be closed 0 to infinity, because x square is always positive, and we have also covered 0, right? Secondly, the value of the function at x equal to 0 is obviously going to be 0, because I have already defined 0 for x less than or equal to 0. And most importantly, this function is differentiable, because x square is a polynomial function, so it is going to be differentiable throughout for x greater than 0. Secondly, 0 is also differentiable for x less than or equal to 0, and at the point of susceptibility, that means where this function is changing its definition, that means x equal to 0, it is again differentiable, because when you differentiate x square, it becomes 2x, and when you find its right hand derivative, it comes out to be 0, and left hand derivative is already 0. So that means this is differentiable throughout, right? Now similarly, we can form other functions as well. For example, the third one I can take as y equal to x minus 1 whole square for x greater than 1, and 0 for x less than or equal to 1. Now just check this particular function for all the conditions. Again, x minus 1 whole square is a polynomial function, so it is going to be differentiable. Its right hand derivative at x equal to 1 is going to be 2 times x minus 1. When you put x as 1 in this, again it becomes 0, and LHD is also 0. So that means this is differentiable at x equal to 1. It is differentiable for x greater than 1. It is again differentiable for x less than or equal to 1. And its range is obviously close 0 to infinity. And we have defined this function for the whole real number line. That means domain is minus infinity to infinity. Moreover, its value at x equal to 0 is also 0, because it's 0 for x less than or equal to 1. Fine. While creating these functions, students, you have to keep in mind one more thing, and that is, since y dash is 2 root y and root y is always positive, so that means y dash is positive. If y dash is positive, it clearly indicates, because in this particular case I am not taking y equal to 0, so if you consider this case also y equal to 0, then you can write y dash to be greater than or equal to 0. So covering all of these functions, one thing is very much clear, and that is we have to form increasing functions. That means those functions that are increasing throughout. All of these functions are going to be increasing. Fine. So this is the third I have written. Similarly, you can write many such functions. So I will show you, we are going to get infinitely many number of such functions. Now let us write few more. This is the fourth function that I am going to write now, y equal to x minus 2 whole square, which is going to be valid for x greater than 2, and 0 for x less than or equal to, right? Now similarly, students, you can write as many functions as you want. X minus 3 whole square for x greater than 3, and then 0 for x less than or equal to 3. So obviously we are going to get infinitely many such functions, hence option D is the correct one. It was really a nice problem, testing the concepts in a proper way. Now we move to the next question. Now students, this is also a nice problem. The question says the number of continuous functions f close 0 to 1 to open interval minus infinity to infinity satisfying the condition integral 0 to 1 fx whole square dx equal to 2 times integral 0 to 1 fx dx is. That means we have to find how many continuous functions can be there such that their domain is close 0 to 1, range is capital R, and they satisfy this given equation. Now if we look at this equation carefully, then we notice that on both the sides of this equation integrals are having same limits. So that means I can rewrite this equation as integral 0 to 1 fx square minus 2fx dx equal to 0. Now to make this integral equal to 0, I can put this integrand equal to 0, right? We won't be getting all such functions that are going to satisfy this equation, but still we'll be getting two of them. Because when I put fx square minus 2fx equal to 0, I will be getting fx into fx minus 2 equal to 0, or from here I get fx equal to 0 or fx equal to 2. Now obviously since they are constant functions, so they will be continuous in this given interval close 0 to 1. So that means we have got two functions like this which satisfy these given conditions. Fine. To get few more functions, what I do, I'll be adding 1 on both the sides of this equation. So I'll be getting 0 to 1 fx square minus 2fx plus 1 dx equal to 1. Right? Now this becomes 0 to 1 integral fx minus 1 whole square dx equal to 1. We have used direct identity a minus b whole square. Now students, how many such functions can you think of which make this integral equal to 1? We know that integral 0 to 1 n x to the power n minus 1 dx is nothing but x to the power n under the limit 0 to 1, which is nothing but 1. I am giving you the example of few polynomial functions. You can find many such functions, but just to answer this problem, I am giving you the example of few polynomial functions which satisfy this equation. Now, when I put n as 1, that particular case I have already discussed, because when you put n as 1, this entire function fx minus 1 whole square will become equal to 1, right? But when I put fx minus 1 whole square as 2x, that means when I put n as 2, now from that we'll be getting irrational function. Right now I am not discussing those irrational functions because the question of continuity may arise, because we have to cover this particular interval close 0 to 1. So we are going to just concentrate on polynomial functions, because we know that polynomial functions are always continuous, right? So let's put fx minus 1 whole square equal to 3x square. Why? Because when I put n as 3 over here, this expression becomes 3x square. So integral of that under the limit 0 to 1 is obviously going to be 1. So that means fx minus 1 will become plus minus root 3x. So one such function can be fx equal to 1 plus root 3x, and another will be 1 minus root 3x. Both of them are polynomial functions of degree 1. So obviously they are going to be continuous. Fine. Now similarly, till now we have got 4. Now similarly you can create many more. You can put fx minus 1 whole square as 5 into x to the power 4. Just put n as 5 in this. So 5 into x to the power 4. When you put fx minus 1 whole square as 5 into x to the power 4, you'll be getting fx minus 1 equal to plus minus root 5 x square. So that means from here we'll be getting fx equal to 1 plus minus root 5 into x square. These are again two more functions. This is polynomial function of degree 2, right? So that means many such functions or infinitely many such functions we can form which are going to satisfy these given conditions. That means option D, more than 4, is correct. Now we move to the next problem. Now this is the next question. It's a question based on definite integral. It's a nice problem. We have to evaluate integral 0 to pi by 2 sin x cos x dx divided upon 1 plus cos x power 4. Now two ways are coming to my mind right now to solve this problem. You can solve it in at least two ways. One is you can divide numerator and denominator of this integral by cos x power 4. You will be getting the expression in terms of tan x, and there will be a term involving secant square x as well. You can put tan x as t so that secant square x dx becomes dt, and then you can solve it further. And another way, I think, is the most effective way, and that is if I rewrite this integral as sin x into cos x dx divided upon 1 plus cos square x whole square. Now students, just look at the numerator, sin x into cos x, and this cos square x. If you put cos square x as t and differentiate both sides with respect to x, what do you get? You will be getting 2 cos x into minus sin x, that means minus 2 cos x sin x dx equal to dt. So that means our numerator sin x cos x dx is nothing but minus half dt. So I becomes minus half outside. Now since I am doing substitution, so I will have to change the limits also. So lower limit becomes cos square 0, which is nothing but 1, and upper limit becomes cos square pi by 2, which is 0. Numerator becomes here dt, and in the denominator we get 1 plus t square. Isn't this method simple? Now this is minus half tan inverse t, limits are going to be from 1 to 0. Now this becomes minus half into tan inverse 0 minus tan inverse 1. We know that tan inverse 0 is 0, and minus tan inverse 1, it is going to be pi by 4. So the final answer comes to be pi by 8. So that means option A is the correct one. Now we move to the next problem. Now students, this is a question on vectors. The question says let V be a vector such that V cross this whole product is there equal to null vector. Suppose V dot j equal to minus 7, then we have to calculate V dot I. Now basically it is the cross product involving 4 vectors. But if you look at this particular part, then it is nothing but vector triple product, right? Now what I am doing, I am writing this product as V cross, and we know that A cross B cross C is nothing but A dot C into B minus A dot B into C. This is the formula to find vector triple product. So we are going to use this. Now A dot C means dot product of these two vectors. So I minus K dot J plus K. So this is going to be how much? This is 0 plus 0 and minus 1. Fine. I think you must be aware of the formula of dot product. If suppose one vector is a1i plus a2j plus a3k, another is b1i plus b2j plus b3k, then their dot product is a1b1 plus a2b2 plus a3b3. So I have just used that thing. Now into B we have to write, so this is 3i plus 4j minus A dot B. A dot B is going to be 3, then 0, and then again 0 into C, and C here is j plus k. Fine. And this product is given to us equal to null vector. So this is V cross. Inside the bracket I am going to get minus 3i minus 4j minus 3j minus 3k equal to null vector. So this is V cross. Students, just take out minus sign common. So you'll be getting V cross 3i plus 7j plus 3k equal to null vector. Now I'm just assuming that V is equal to xi plus yj plus zk, right? So that means this particular product now becomes how much? We can calculate cross product by this determinant. This is ijk xyz 373. So this becomes I into 3y minus 7z minus j into 3x minus 3z plus k into 7x minus 3y. Right? Now, this cross product is given to us equal to null vector. So that means this particular value is a null vector, and this is going to be null vector only if each of the I, j, k components of this vector become 0. So that means 3y should be equal to 7z, 3x should be equal to 3z, means x should be equal to z, and 7x should be equal to 3y. Fine. That means I can write now seven x equal to 3y equal to 7z, or we can also write x equal to 3 upon 7y equal to z. I have divided by 7 throughout. Now we are given that v dot j equal to minus 7. What is v dot j? V dot j is nothing but y, right? And this is given to us equal to minus 7. So that means y is equal to minus 7. If students y is equal to minus 7, just put the value of y equal to minus 7 over here. You are going to get x equal to 3 upon 7 into minus 7. This is minus 3. And what is x, by the way? X is nothing but v dot I. Right? So that means our required answer is option A, minus 3. Now we move to the next question. Now this is a nice problem. The question says, in a multiple choice test consisting of 8 questions, each question has 4 options. For each of the questions, exactly one of the 4 options is the right answer. A student answers all the questions by choosing one option for each question. The number of ways in which the student can get exactly 5 correct answers is. Now, suppose student has to attempt the questions A1, A2, A3, A4, A5, A6, A7 and A8, right? And all of them are having the options, suppose A, B, C, D, right? Now, only one of the options for each of these questions is correct. And the student has to attempt all the questions and he has to answer only 5 questions correctly. That means 3 questions he is going to answer wrongly. 5 right answers and 3 wrong answers. So the total number of ways in which this can be done is first of all will be selecting 5 questions that he has to mark correctly out of the 8 given questions, right? And he can answer them in only one possible way because they are having only one option correct. Fine. Into, because we have to also take those questions or take into account those questions which he is marking wrongly. So that means there are 3 questions. Since we have already selected the 5 correct ones, so 3 have been selected already. Now the question is how he is going to mark those questions wrongly. That is most important, because suppose he attempts A2 question wrongly, then suppose answer of A2, correct answer of A2 is A, then either he can mark B, C or D, because he has to answer this question wrongly. So that means there are 3 options for one question, 3 options for another one, and 3 options again for the third one, because ultimately he has to mark 3 questions wrongly. So this is going to be the final answer. Let's simplify this. This becomes 678 into 27 divided upon 6, because factorial 5 has been cancelled up and down. So this becomes 56 into 27, and when you just simplify this, this comes out to be 1512. So option D is the correct one. Now we move to the next problem. Now students, this is a nice problem on geometry of complex numbers. The question is the minimum value of the expression mod z plus mod of z minus 1 plus mod of z minus 1 minus iota plus mod of z minus iota, where z is a complex number and iota is equal to square root of minus 1 is. Now what is this? Mod z is the distance of z from origin. Suppose z is a complex number, and mod of z minus 1 is the distance of z from the point 1 comma 0 in the Argand plane. Similarly, mod of z minus 1 minus iota is the distance of z from the point 1 comma 1 in the Argand plane, and similarly mod of z minus iota represents the distance of z from the point 0 comma 1 in the Argand plane. So what do? We just make x and y axis in Argand plane, where we can plot complex numbers. This is origin. This is the point 1 comma 0. This is 0 comma 1, and this is, let's say, 1 comma 1. Now if I join these points, clearly I am going to get a square of length 1 unit, right? Now let's make its diagonals. Let the point of intersection of the diagonals be O. Suppose these are the points A, B, C, D, and suppose Z lies anywhere in this plane. I'm just taking Z over here at the point P. Fine. Now it's very much clear that when we join P with A and C, fine, then I can definitely say that PA plus PC will be greater than or equal to AC. Why I'm writing this? Because if P lies on AC, suppose P lies somewhere inside A and C on the line segment AC, then obviously PA plus PC will be equal to AC. But if P does not lie on AC, it lies somewhere else in this plane, then even in that situation, if it is forming a triangle inequality will hold. and we can say that PA plus PC will be greater than AC. Suppose if P does not lie on AC internally, but it is lying on AC externally, even then PA plus PC will be greater than AC. So that means in every situation I can say that PA plus PC is greater than or equal to AC. Fine. Let's call this inequality number 1. Now similarly we join PB and PD. From here what we can say? We can say that PB plus PD is greater than or equal to BD by using the same reason, right? Now, is it possible for both the inequalities to become equalities? Yes, this is possible at the same time when P lies on both the diagonals. That means when P coincides with O, P becomes the point of intersection of O, or I can say P becomes the point of bisection of these diagonals. In that case, PA plus PC will become equal to AC and PB plus PD will become equal to BD, right? So we can definitely add these inequalities to write PA plus PB plus PC plus PD is greater than or equal to AC plus BD. So hence I can say mod of Z plus mod of Z minus 1 plus mod of Z minus 1 minus iota plus mod of Z minus iota is greater than or equal to. Now what should be the length of AC? Since AC and BD both of them are the diagonals of the square, so from here AC is nothing but root 2. So this quantity AC plus BD is going to become how much? It is just 2 root. Fine. So this expression will attain minimum value 2 root 2. That means option B is correct when this complex number lies at the point of intersection of these diagonals. Now we move to the next question. Now this is the next question. The question says the number of real numbers x such that there exists an isosceles triangle having two of its angles measured in degrees equal to 2x plus 7 and 7x plus 10 is. Now there are different cases that we need to cover. Is the first case is that triangle is isosceles with two angles equal to 2x plus 7 and the third angle equal to 7x plus 10, right? So that means 2x plus 7 plus 2x plus 7, or I can say 4x plus 14 plus 7x plus 10 equal to 180. So it becomes how much? 11x plus 24 equal to 180, or we get 11x equal to 156. So from here the value of x comes out to be a real number equal to 156 upon 11. Fine. It is 14 point something, right? So that means by putting this particular value of x, we can create an isosceles triangle, two of whose angles will be equal to 2x plus 7 and the third angle will be 7x plus 10. I am not interested to find the angles over here because we are just interested to find the possible values of this x. How many x are possible such that we are going to get different isosceles triangles. Now, second case can be when both of the angles which are equal to 7x plus 10. And the third angle is of the measurement 2x plus 7. So that means you will have to solve for this equation to check the range for the angles. It should not happen that some angle is exceeding 180 degree or we are getting two angles more than 90 degree, because such kind of cases are not possible. This is why I am forming the equation 14x plus 20 plus 2x plus 7 equal to 180. So this becomes 16x plus 27 equal to 180. Or from here we get 16x equal to 153. So this means x is equal to 153 by 16, or this value comes around 9 point something, right? So that means if I put x as 9 point something in 7x plus 10, it is going to be somewhere around 73 point something. So these two angles are permitted, 73 point something, and the two angles are of this measurement, and the third angle is going to be how much? It is going to be around 25 degree, because 18 point something plus 7, it is 25 point something. So these angles are quite possible. And what can be the third case? Is third case possible, or only these two cases are possible? Here you have to use little bit of your mind, and that is, this is possible that there is an isosceles triangle such that it is saying having two of its angles measured in degree equal to this. Fine. So what I am doing, I am taking one angle as 2x plus 7 and another angle as 7x plus 10. I do not know about the third angle. So obviously, let us check whether we get the third angle in the suitable range or not. Because we have to ultimately fulfill the condition, and that condition is two of the angles of this isosceles triangle must be 2x plus 7 and 7x plus 10. But I have to make this an isosceles triangle. It means I will have to put 2x plus 7 equal to 7x plus 10. Earlier, what I was doing, I was taking two equal angles as 2x plus 7 or two equal angles as 7x plus 10. But this time I have made 2x plus 7 equal to 7x plus 10. Fine. So from here also we are going to get a value of x, and value of x comes as negative 5x equal to minus 3. So x becomes minus 3 by 5. They have said how many real numbers x. So x can be negative as well, but angle must be positive. Fine. So when I put x as minus 3 by 5, then angles are going to be how much? Let's calculate them. 2x plus 7 will certainly be positive, because it is going to become minus 6 upon 5 plus 7. So it is minus 6 upon 5 plus 7 is 35 minus 6, which is 29 upon 5. Fine. This is one angle. Another is again 29 by 5, because 7x plus 10 has to be equal to 2x plus 7. So this angle comes around how much? 5 point something, right? This is also 5 point something. So when we add them, we get 10 point something. So obviously, if we subtract their sum from 180, this angle is going to be obtuse angle, and this will come as 180 minus 58 upon 5. I'm not calculating it. I just wanted to check whether the triangle is feasible or not. Is it practically possible or not? So it is possible. 180 minus 58 upon 5. 180 minus 58.5 means somewhere around 168 point something, because 58 upon 5 is going to be 11 point something, right? So it is possible. So that means now we have three possible cases. That means three triangles are possible, and we are getting three different values of x. First was 156 upon 11, second was 153 upon 16, and third is minus 3 upon 5. So hence D option is the correct one. Now we move to the next question. Now this is the next question. The question says a disease affects 2/3 of the population of a country. A test for the disease gives the correct outcome with probability 2/3. A person X tested positive for the disease. The probability that X has the disease is. Now students, from the language it is very much clear that we have to use Bayes theorem in this question. Now if I assume the event E1 as a person tested has the disease, actually, that means it's not the positive report given by the test, but that person has the disease actually. And second is the case a person does not have the disease. This is E2 suppose. And what is E? A person has been tested positive. That means test result is showing that he has the disease, right? Now what we have to find in this question? Why I'm saying I'm going to use Bayes theorem? Because we have to find the probability of sub-event, and it is given that main event has already happened. That means in this particular question we have to find P E1 by E. So this is nothing but P E1 into PE by E1 divided upon PE, and PE is going to be PE1 into PE by E1 plus PE2 into PE by E2, right? Now PE1 is how much? A person tested has the disease actually. It is saying that 2/3 of the population of a country is suffering from this disease. So that means PE1 is 2/3. PE by E1, that means the person is having that disease. It's there that the person is a patient of this disease, and when he is tested, then test result also shows that he is having that disease. That means the outcome is correct. So this is also 2/3. Now divided by 2/3 into 2/3 again plus PE2. PE2 means the person does not have the disease. Now obviously if 2/3 of the population is suffering from this disease, then 1/3 of the population will be free from this disease. So this is 1/3. And PE by E2. E by E2 means the person is not having the disease, but the test is showing wrong outcome. So if the probability of correct outcome is 2/3, then the probability of wrong outcome must be 1/3. It is 1 minus 2/3. So when we do the calculations, it becomes 4/9 divided by 4/9 plus 1/9, which is 5/9. So finally this comes out to be 4/5. Hence option D is the correct one. Now we move to the last question of this video. Now students, this is the last question of this video. The question says the value of the integral 0 to infinity dx upon 1 plus x square into 1 plus x whole square is. It's a question based on substitution. We will have to look for the right substitution. Let's put x equal to tan theta. Now when we put x equal to tan theta, then dx becomes secant square theta d theta. So I can write dx upon secant square theta equal to d theta. That means dx upon 1 plus tan square theta, or dx upon 1 plus x square equal to d theta. Now since we have used substitution in this integration, so we'll have to change the limits as well. So if this is integral I, then I becomes, initially we had x equal to 0 as the lower limit. So when I put x equal to 0, then tan theta is 0, means theta is 0. And upper limit we can find by putting x as infinity. So that means theta is pi by 2. Right? Now dx upon 1 plus x square is replaced by d theta. And in the denominator I am having 1 plus tan theta whole square. Now what we should do after this? What I am doing, I am using the property 0 to a fx dx is equal to 0 to a f of a minus x dx. So that means now I can write, suppose this is the first equation. Now I am writing I equal to integral 0 to pi by 2 d theta divided upon, it was 1 plus tan theta square. So now it will become 1 plus tan 90 minus theta whole square. Means 1 plus cot theta whole square. Fine. This can further be written as 0 to pi by 2. Now just put cot theta equal to 1 upon tan theta. So it is going to become tan square theta in the numerator, d theta, divided upon 1 plus tan theta whole square in the denominator. Now students, this is our equation number 2. Let's add equation 1 and 2. So what do we get? We get 2i equal to 0 to pi by 2 because the limits of both of them is same. So 2i becomes 0 to pi by 2, 1 plus tan square theta d theta divided upon 1 plus tan theta whole square. Because denominators of both of these integrands was same. So LCM is just 1 plus tan theta whole square. Now in this particular integral, if I put tan theta as, suppose, t, I am putting tan theta as t over here. What do I get now? I'll be getting, now when we put tan theta equal to t, the integral becomes 2i equal to 0 to infinity, because now we'll be changing the limits as well. And in the numerator we had 1 plus tan square theta d theta, which now becomes secant square theta d theta. And since we have put tan theta equal to t, so secant square theta d theta becomes dt. In that denominator we now have 1 plus t whole square, right? Now this is how much? Dt upon 1 plus t whole square means it is t plus 1 to the power minus 2. So the integral is nothing but minus 1 upon 1 plus t under the limits 0 to infinity. Now this becomes 2i equal to, I am taking out minus sign. This becomes 1 upon infinity, which is 0, minus 1 upon 1. So this is just 1. So 2i becomes 1, or I becomes half. Now option B is the correct one. Now students, I am ending this video over here. And very soon I will be coming up with the solutions of part 2 mathematics section of this paper as well. So keep watching my videos. If you haven't subscribed this channel till now, then I would suggest you to subscribe this channel for many such videos in future. Thanks.